Well, welcome. Thank you for coming to my talk about IP Route 2. I'll start off by telling you a little bit about myself. Surprisingly, maybe to you guys, I'm a consultant, but I like doing technical stuff as well. And what we're going to be talking about today is pretty technical, so I hope you're up for it. It should be a bit of a ride. I'll start off at the beginning, and I don't know, does anyone recognize this thing? Yeah, it's a NIC. It's a TP-Link RTL8139 chipset, which was very, very common chipset about 15, 16 years ago. And this is what you put into a router. And another one. And the router used to look like something like this, which is basically a big, huge black box. And you put the NICs in the back. And each NIC had its own driver, its own binding. It was quite messy. You needed lots of these boxes to make a nice network. And nowadays, life has changed. Hello. What are you saying, Hans?
You need the mic for the video.
Oh, okay. Well, fair enough. I don't think I can hear myself, but... So this is what a router looks like nowadays in a lot of situations. This is not a corporate situation, obviously. Then you have a nice little Cisco thing. But you can see that it looks very, very different from those boxes we used to have. And if you look at what a router does nowadays, it's completely different. It used to just be RJ45 Cat5 cable go through. And now we have, this is the latest thing I could find by Netgear, which I think it looks really cool. It's the Nighthawk X6 AC 3200 tri-band Wi-Fi router model R800. Which has loads of things. It's like, if I read this, I'm just sitting there going, oh my God, you could do this just on one little box this small. It does laptops, tablets, phones, TVs, game consoles, music streamers, cameras. It's all Wi-Fi enabled. Huge amounts of throughput, 3.2 gigabytes per second. And oddly enough, you know, it looks a bit outlandish, but it's not anything else than what we expect nowadays in this day and age. You know, I saw one of the Arduino talks. This guy had a chip this size, and he used it to do 8-bit throughput operations, which I thought was incredibly clever. And then you can imagine, well, the hardware, that NIC, or that set of NICs, it doesn't need to be in there anymore. Interfaces have changed as well. When I was doing routers back at the beginning, and on those big black boxes, this was your interface, and probably most of you guys will recognize this. Nowadays, router interfaces, if you can't see it properly, it says root at Debian because I use Debian for routing. A little thing, it's just command prompt. Nowadays, if you look at the interface to one of these routers, it looks a bit more like this. Isn't it cool? It's got, like, you know, your IP address and subnet mask and your DHCP server. It's got a DHCP server in there. It's got everything. It does natting, and they're all laid out really prettily in absolutely beautiful and easy to use, especially for home user kind of ways. And if you don't like to have the sort of standard what your router offers, and you see, I want more power, you do this. You know, you flash on open WRT. It's an open thing. It does a lot. It has all the functionalities, and it's all clickety-click. But there's a problem. And the problem with all of these control panels is the functionality does stop somewhere. At one point, you can't do what you want to do anymore. And for that, you need to go back to the command line. That's what I'm going to be talking to you about today. So there's two use cases. This is actually, as you can see, it's a nice old picture. And this is where the problem that we're addressing today comes from. We have a couple of network cables going out there to different internet providers. And we have a satellite dish coming back. Now, why would you want to do that? Generally, upstream on satellite communications is like virtually zero, if you can buy it. And if you do buy it, it's incredibly expensive. Downstream, however, is very fast, it's very effective, and it's very nice to have you. It's also very mobile nowadays. Whereas when this drawing was made, yeah, you can see 256K frame relay up there. It's an old drawing. we started doing things like we moved from the phone lines into cable internet. Now, I don't know if you had the same evolution of internet here as we did in the Netherlands, but basically when the cable internet came, we were all like, oh my God, you know, it was a 256K line. It was slow and it was buggy and it kept dropping, but it only cost us 10 euros or 20 euros, guilders at the time, per month. That's really, really cheap. Now, satellite, we could also get really, really cheap. But, yeah, no upstream. So how do you route this? And the answer is actually, surprisingly, maybe a bit simple once you know how it's done. But finding out how it's done is a bit of a problem. So how does this problem translate to today? It becomes this picture. And that's where we say we use the outgoing traffic of a mobile GSM because generally when we're surfing the web or we're reading emails, that kind of stuff, our upstream demands are low, but our downstream demands are higher. That's just not changed at all. In a mobile phone, though, yeah, I don't know what the data plans are like here, but generally in the Netherlands, if you can get 4 gigabytes, that's a lot. But as soon as I start going to the EU, I start having to pay through the nose for capacity. So I have some capacity. Hans here has 1 gigabyte roaming through Europe, but as soon as he gets outside of Europe, he's in trouble. It's measured in euros per megabyte or per 10 megabytes. And I can do megabytes up, just sending post requests, you know, get requests. That's easy, that's small. But I can't go down because, yeah, you know, I look at a page like Facebook, or if I'm a journalist and I want to look at the Reuters pages, suddenly my downstream starts increasing hugely. So I want a satellite dish. And satellite communications used to be these big, you know, these big dishes with the LMB on the front. Nowadays you can get them fairly manageable size. All right, now on to the technical part, which I hope you guys are all here for because that's what the rest of this is going to be. There's some real basics, which if you don't do them right, will really screw you up, and you can spend hours looking for why are things not working if you don't do this. Enable IP forwarding. It's just one of these stupid little things which, if you don't do it, won't work, and you just won't be able to figure out, looking at log files, why it's not forwarding. It's basically, here you can see I've given you 2 different commands, either echo 1 and turn it on that way in the kernel, or sysctl for those people using systemd. Now, I'm not a big, huge systemd user yet. I'm a bit old-fashioned there. So I've given most of my examples in the old way, but where I know how it's done, also the sysctl. Now, the same goes for nowadays. It's, you know, if I look at a laptop, or this is not my laptop, but my laptop, it runs VirtualBox, and it has lots of virtual machines, and I use them for different things. And it's incredible to me that when you create a new virtual machine, generally the standard setting is to have the NIC in NAT mode, which is great if you don't mind having an IP of 10.0.2. something. But yeah, as soon as you start going, hey, where is this 10.0 coming from? And you're looking through the logs and it says, yeah, I got it from DHCP. And then you get really worried because you don't have a DHCP server at the 10.0.2 range. Yeah, you can start looking for crazy things. And it's just a simple little setting that you need to change when you're setting up a virtual machine. So, leaving already. Bye-bye. So, off to interfaces again. Now, does this look familiar to most of you guys? I guess maybe, hopefully, yes. Etc. network interfaces. What I'm basically doing is I'm saying, yeah, I've got a static internet connection. I'm calling this my mobile internet connection. Yeah, I'm cheating a bit, and I'll tell you why later, but this is basically in Linux how you set up a network interface to a fixed address on a fixed broadcast range. Then I have this file, which I think that maybe you guys won't be so familiar with. Some of you maybe, some of you might not. But for me, when looking up this one, is this file, which took me a long time to find. And what I've done is at the bottom, I've said 8.2, which is basically this 8.2, because it helps me to remember. That's my mobile network, and I will be adding a 188 IP address, and that's my satellite connection. These tables, they've been built into IP route 2. There are many more for policy routing. And so before we go further into this, I'm going to tell you something about this, because there are many ways to do IP routing, right? And most of you will probably know route minus n to get a routing list. Or maybe you'll use netstat minus rn to get your routing list. How many of you guys use IP route list? There's 2. It's not very many. This is IP route 2. Basically, it's just this little command, IP, it does everything. And you can see that the output is pretty small. It's very compact. And it looks a bit less easy to read, maybe. But it has more information in this than you have here. So slightly, you might have to get used to it. So, you know, here we can see what the network ranges are, which you can't see on there. And we can see what the scopes are, which you can't really see on there. Well, here you have the IP address list command. I'm going to get back to what's on top later on. Now, the IP address list, do you guys, I guess the same 2 guys know this one who knew the other one, and I guess most of you guys use ifconfig. Yeah. ifconfig looks really pretty, doesn't it? It's everything, all the adapters are very, very easy to find underneath each other. This looks slightly different, but again, it's more compact, and it has more information at the same time, and it uses the same command, IP. Everything comes from IP. And if I have a look at the ifconfig output, yeah, it looks more friendly because it's got this beautiful tab. I like the tab. And, you know, everything's nicely under each other. So this makes this look quite ugly, doesn't it? But more information in less space and run from the same command. Now, I'm going to add a second IP address, my satellite, that's the 188, onto the same NIC. Why am I doing that? Well, generally because I might only have one NIC in my laptop. That's especially with the really thin ones. Nowadays, you have to even plug a little extra thing into it with one network jack. So I need to have multiple IP addresses running through the one interface. Well, IP addressing, if you do this via ifconfig, yeah, what you would do is you'd say something like ifconfig etho, and then the IP address, that's it, you're done. So this looks like a big mouthful. It is a big mouthful. That's another advantage of IP. It's way more precise. Yeah, you can tell it exactly what you want to do, and you can't tell ifconfig to do it this way. So I'm limiting my broadcast range here. I'm giving it, I'm telling it which device to connect to. I'm saying it's an extra number. It could be 1, could be 10, could be 99, whatever you like it to be, I think sequentially, so 1. And I'm giving it a label. I could call it sat. I could call it etho1 underscore sat. This one works for me. Now we also have to prepare some more once we're doing this, and that's because we have to disable reverse path filtering. And we're going to be messing with that. We're going to be changing how the packets that go up come back down and then go back out up again, right? So that means that if your kernel checks your incoming path, it'll say, hey, yeah, but it was sent out via a different outgoing path. That's what reverse path filtering does. So we have to disable this. Well, there's a systemd way, and there's my old-fashioned way for whoever wants to do it. It's not very difficult, and yeah, it's quite useful to check if you're dropping packets. If you disable the if you start logging the Martians, this is what the Martians are for. They'll tell you you're dropping packets on the way on both routes. Now, a friend of mine told me that, and that friend is Hans, that my slides were a bit boring and that I needed to have a bit more humor in them. So here's a funny picture. Okay. All right, now then we have a problem. We have basically two NICs, two separate networks completely, and the default gateway won't work. Why not? Well, yeah, because basically, if you send it out, it'll say, yeah, I'm coming right back at you. I'm coming straight back down. And we don't want that because, well, we want the satellite. It's a it's a broader bandwidth. And also it's expensive to do it via mobile. Now the way to get around this is, once you know how it's done, really quite easy. It's called asynchronous or asymmetric or loopy routing. Yeah, and this is one of the things that probably people get a bit upset about, because finding these terms on Google is quite tough. But basically, it makes sense to call it loopy. You know, you're going up one way, you're going back down the other, you're going up one way, it's a loop. And we do it basically with this command. We say IP route at default via my mobile, and then I say source 188.204, that's my satellite. What is this? Does anyone know what this means? What am I doing? Yeah. What I'm saying is I say go out through the mobile, send, receive. Well, I'm not saying receive via satellite. I'm saying pretend that the packets which have gone out are from this IP address. No. Basically what I'm doing is I'm spoofing. This is IP spoofing. You can do it via the firewall as well. Basically this rewrites the outgoing packets to say that that the output IP address should be this. Yeah, well, yeah, that's one of the reasons we need to disable reverse path filtering, because your guys upstream won't be able to see it, but you, on your router, knows that your kernel knows exactly what it's doing, right? So it's saying, hey, man, I'm getting these packets coming back, and they're saying they're coming from the satellite network, but dude, I sent it out. It can't be. It's a reverse path problem. Yeah, because it is basically a really complicated way of spoofing your IP. That's generally not allowed. Now, the guys upstream from your internet connection, they won't see this. They don't mind. They just see this packet being rerouted through. They send it through, and they say, okay, it comes back in. So that's how you make the actual loop. Yeah, you basically send out, and you tell your gateway at IP level, I would use this and not this, because this is much lower on the kernel network stack than firewall, and once your firewall goes to pot, you know, then that's the end of it. And plus nowadays, generally in networks, firewalls are separated from your IP, from your router. So I'd use this one. But you do run into a problem, and that is on a mobile network, you can't really control what the routing table is of the network provider, and that's why I was cheating when I did this. Because what happens when you connect a mobile to your laptop or whatever, your phone, whatever, you get an IP assigned to it by your network provider, right? Which means that you can't actually say, yeah, give me this address, and then use this address as a source address, because it changes all the time. So you're working with a dynamic IP thing, and you can't write to the routing table of the mobile provider. That's a problem. So how do we solve it? Ta-da! There is a solution, and that is using a dongle. Now, I've chosen this dongle because I know it works on Linux, which is quite useful. Basically, you put the SIM card in this, and if you issue an auto USB 0 and an iFace, in etc. network interfaces, it will assign you an IP address. It'll be something in the 10.00 range, but it also comes with a little web server on it. Nowadays, everything has a web server. It's really amazing. And you can log into it, and you can change your IP address so you can make it look like whatever IP address you want. You can reroute this the routing table to this machine, because you control this IP address. That's how we solve that problem. All right, now for satellite down, what should you use? Well, in the EU, most people use the Astra satellites. The actual hardware that you use is always very straightforward. It's a bit like, you know, receiving a modem or something from an internet provider. They will tell you, this is your IP address, this is your IP range, this is the gateway you use, these are the DNS servers, etc. It's a very, very well-documented process. So I'm not going to go into that anymore. You can find your own satellite stuff from, you know, the James Bond tiny spy stuff to the big old dishes, you know. That's up to you. And now for something a bit different, because, you know, it wasn't just mobile up, satellite down. And that's really it, yeah, this is how you do it. This is how you get that loop going. I'm a bit nervous because of this time thing. Yeah, everyone's been delayed and stuff, so, and Hans is sitting here, so I'm speeding through it a bit. Here's another situation you can get into, with, which is resolvable. You can have multiple ISPs and you have multiple networks behind your router, and you will want to route from different networks through to different ISPs. So, for example, very simple one is, I don't know, do you guys do web development or that kind of stuff? Hosting in-house. This could be your server farm. You have a glass line lying there. But for your office, you want to have a different network because you don't want them to really be touching. So you want them to be running concurrently, and you want to be able to have one take the other one over should it fall down. So in general, you want network A to be going up over this one, and network B, your internal network, to be going over that one. But sometimes this ISP will just drop, and you have to go back through that. Well, again, we have a bit of a problem, and the problem for that is we only have one default gateway. And I don't know, have you ever done, probably route add default gateway would be the way you've done it, and then try to add another one. It says, no, can't. Doesn't like it, because it's the default gateway, you know, that makes sense. So, what I'm going to do is I'm going to add rules, and this is where these RT tables, we go back, this is where this comes into play. I have a table called mobile and a table called satellite. So, I take this is my mobile one, and I say IP route add all of this, and I say that route has to be looked at through table mobile, which is the one I defined in that RT tables file. Then I say, yeah, and I want to add the default via in table mobile. And then I say, I have to add a rule, because it's policy routing, and this is like a policy, and say, add all the traffic, as a rule, all the traffic in this network, I want you to be looking at the table mobile when you're looking at this. Now, the strange thing is, if you go to IP route list, this is what you'll get. So this is actually exactly the same IP routing table that we saw earlier. Don't know if you can see that. Nothing seems to have changed. Now I'm going to add my second NIC, the satellite one, in exactly the same way, except I say, yeah, no, I want that whole network to be routed via the satellite table. I want that one, the default gateway, to be via the router, the gateway IP in the satellite table, and then I want to add a rule saying all of that network traffic, I want you to look up in the satellite table. It's a bit of a roundabout way of doing things, but this is the way it has to be done. And if you do IP route list, then you get this, which is exactly the same as what we got just now. So. It's there, but you can't see it using this, and that's because you have to look up the rules. So in the rules, you can see much more verbosely what the order is of the lookups. Yeah, so all the satellite stuff, it says look up in table satellite. all the mobile stuff, look up in the table mobile. And then you go, whatever else is out there, look through the main table. So that's the one which will be the normal default gateway that you've added. Yeah, the one you've added, not in a table, not in a rule. With IP route list table mobile, you can look at the routing table for the mobile connection. And then you can see, haha, it's a default via that and via that. And I see I forgot to do, oh no, I didn't, here. This is the mobile table and this is the satellite table. And you'll see this is the default via the 82 network. And then this is the default via the 188 network. So you have basically 3 default gateways depending on what rule you are referencing. And that rule depends on what network you're coming from. Now obviously you can use this. You can use this to do funny stuff with. So, you know, if in one of these command lines I say source, now here, source, and I add this, one of these, the IPs in this range, yeah, I'll start creating a loop from mobile, or from satellite to mobile. And if I do it the other way, so I can loop things all over the place if I really like to. I don't know if you want to do that always in this situation. But basically what I've done is I've created a very, very easily changeable situation where if one of the routes goes down, you know, it's very easy to just say, I'm going to use the other route for everything. So I just change the rule. Now, having to type this all in every time is a bit annoying. So this is what it looks like in network interfaces. And what you'll see is I specify the network addresses, the broadcast gateway, etc. And then I say the DNS name servers for all 4, well, I have 2 networks, so 4 DNSs are given in there. And then I do something, I say post up and post down. So basically I'm telling the networking script, after I brought up this one, because this is my default standard everything, you know, and this doesn't have to be in any of these networks. But after I've set up, then I want to start building the extra interface for the extra NIC. So here, because I've already got this as the same NIC, I don't have to say add the interface. I just say no. I add the route, I add the default gateway, and I make a rule to look it up in the table. And then I say when post down. So when a SIGINT is thrown, when it's the machine is told to shut down, I say post down IP rule del from table. Just delete the rule, because otherwise you end up getting weird routing artifacts in the caches of the machines around the router. And the same goes for second NIC. I use basically the same commands: post IP up, post up IP add. And I bind the second IP to the first NIC. I add the routes and the default gateway. I add the rule, and then in the down script, I say, yeah, not only do I want to delete the rule, I also want to delete the virtual NIC. Yeah, so the second IP address. Now, most of you will have a firewall. I'm using Shorewall. I don't know if you know that, but firewalls generally don't like this situation much, so you're going to have to do something about it. Now, in Shorewall, in the interfaces, I have to say, I've got a route back system. So allow packets from different IPs to come in within this device. So if you don't do that, it will start saying, yeah, no, this is the only IP address. And you'll find that more services need this. Mail is a very, very important one. So, you know, for postfix, you need to add the new IP to my networks. And that's one of these little things that is quite easy to forget. You know, I think SNMP, for example, as another one, you will need to tell that you have multiple networks now. It's not just one easy network to do. So, because we like frogs and because it's been quite dry, I would like to thank you for your attention. You can find more information on this page on my wiki. I guess we'll be giving the presentations. Basically, this has all this information. You just copy-paste it. But it also has a lot of links to the source files. And if you really, really want to get serious about learning IP, most of the resources on that page are very, very accurate. Policyrouting.org, Linux IP, and LIRTC are also huge sources of information if you want to get really, really complex. And the frog is there because we need more funny pictures. So, thank you for your attention. Do you have any questions? Did it make sense at all? Was it kind of what you were hoping for?
Thank you, Robin. Ovime završava drugi trek. Stignemo još na 2 predavanja u prvom i podsjećam da je u 20 sati proslava 20. rođendana Hulka.